Hi there and welcome back to our course. So in the last lessons we have covered 3 different types of linked list, which are single linked list, circular single linked list and double linked list. Now from this lecture we will start to learn 4th type of linked list, which is circular double linked list. Before diving into deep, let's quickly recap what is the difference between double linked list and circular double linked list, and why do we need circular double linked list. Okay, we know from previous lectures that in double linked list, each node has 2 references which link them to the previous and next node. This provides flexibility of traversing forward and backward. This solves the problem of traversing backward that we have in the single linked list. But there is a limitation in double linked list. Let's say we have an application that requires to go from the last node to the first node of the linked list. In case of double linked list, we cannot do that because the last node reference to null. So the circular double linked list solves this problem because here the last node reference to the first node. As you see in the next reference of last node, we have first node's physical location. And similarly, first node points to the last node. So here, the previous reference of first node is the physical location of last node. So the problem of going from the last node to the first node and from the first node to the last node is solved here. Now we have quickly reviewed how a double linked list differs from circular double linked list. Okay, let's continue to learn circular double linked list in depth. As before, we will go through different operations that we performed before on other types of linked list, such as creation, insertion, traversal, searching, and deletion. Now in this video, we are going to learn creation of circular double linked list. The creation of circular double linked list is very simple. As before, firstly, here we create a blank node. Let's say the physical location of this blank node is 001 in RAM. The next step here is we need to insert a value in it. Let's imagine that in our case it's 11. After assigning value to it, we need to create a link between head and this node over here. So to create a link between head and this node over here, we need to update the head's reference to the physical location of this node here. So by updating head to the physical location of this node over here, we are creating a link between head and this node. Now, we know that this is the only node in our circular double linked list, so tail reference has to point this node also. So if we update the physical location of this node over here to the tail, it will create a link between tail and this node over here. And finally, as a last step, we have to update previous and the next references of this node over here. And we know that in circular double linked list, the first node reference to the last node and the last node reference to the first node. This means that previous and the next node of this node over here will be itself, as we have one node in our double linked list. So this is the first node and this is also the last node. So the previous and the next reference of this node will be itself. So by updating previous and next references of this node to itself, we are creating a link with itself. Now let's see what the algorithm of creation of circular double linked list looks like. So the algorithm starts with taking a node value, then it creates a blank node and assign this value to the this node's value that comes from the parameter. Then the next step over here is we are creating a link between head and this node. So by setting head to this node, we are creating a link between head and this node. Then, so as we know, this is the only node in our circular double linked list. So here, tail has reference to this node also. So here we set tail to this node. Then the next step over here, we need to update next and previous reference of this node. So in circular double linked list, we know that the first node's previous reference points to last node and the last node's next reference points to first node. As this is the only node in circular double linked list, both next and previous references have to point to itself. So we set both of them to node, which is itself. Then we terminate our algorithm. Now based on this algorithm, let's switch to Visual Studio Code and create creation method for circular double linked list. Here again we have created separate file for circular double linked list as we did for other type of linked list. So inside this file we have created node class. So this is the same class that we created for double linked list. Here we have next and previous references and value. Then we created circular double linked list class in which we set head and tail references to none. Then there's a iter function over here. By using iter function, we make our circular double linked list iterable. So the only difference that we have over here, so we put in condition inside while loop because we know that in case of circular double linked list, the last node points to the first node. So when we reach the last node, it will come to the first node and the loop will be infinitely. To prevent this case, we put if condition over here. When we reach the last node, we break our loop over here. So this part of code is almost similar for all types of linked lists. So after this, we will create creation method over here. So according to our algorithm, we will define our create method, create circular double linked list. So by default, we know that it takes self parameter, and according to our algorithm, it will take node value. Then the first step in our algorithm to create a node based on this node value over here. So we will create new node, and we will use node class that we created over here, node class and node value that comes from the parameter. Then the next step is we need to create a link between head and this node and tail to this node. So because this is the only node in our circular double linked list, so head and tail will point to this node. So self.head equals new node, and self.tail equals new node. Then the next step is we need to update previous and next reference of this new node over here. We know that in case of circular double linked list, the first node points to the last node and the last node points to the first node. So if this is the only node in our double linked list, the previous and next references will be point to itself. So I will set previous reference of new node to itself, new node, and next reference of new node to itself. Then we return saying that the circular double linked list is created successfully. So with this we complete our method of creation of circular double linked list. So now let's see how this is working in practice. So here I will create circular double linked list like this. Double linked list equals circular double linked list class. Then inside this class we will call our method dot create. For example, let's say it's with the value of 5. Then after this, to see that if this is created or not, we can print out our circular double linked list. So as we said before, by using iter functionality, we can make our circular double linked list iterable. So by using this expression over here, we can print out our circular double linked list. So before running our code, let me just print out this code from here, because we know that it returns this message from here. So to see this message, we need to print out the value that comes from this method over here. So let's run our code. You see that after running the code, it says that circular double linked list is created successfully, and we print out our circular double linked list in which we have only one node and the value of node is 5. So our method works correctly. Now let's see what is the time and space complexity for this method over here. Now, as always, we will start from the first line of code in the method. So in the first line of code, we create new node and assign value to it. And we know that creating a new node and assigning value to it takes O1 time complexity. Then in the next line, we create a link between head and new node, and this takes O1 time complexity also. And then creating a link between tail and new node also takes O1 time complexity. Then we continue to update previous and next references of this node, and this also takes O1 time complexity, and returning a message takes also O1 time complexity. So if we combine all these complexities over here, the time complexity for creating circular double linked list is O1 time complexity. Now you might be interested, what is the space complexity for this method over here? So the space complexity is also O1, because here we are just creating only one node. So creating of one node does not take an extra space in the memory. That's why the space complexity is O1. Now this is all for this lecture. In this lecture we have learned how can we create circular double linked list, and we have learned what is the time and space complexity for this operation over here. Now in the next lecture, let's see how can we insert a node to the circular double linked list. So see you in the next lecture.